So we have another problem here that is going to use the parallel proportionality theorem. Notice that the parallel lines are vertical, but this is really very similar to problem number 5, where the parallel lines are horizontal. If you like to, you can turn this on its side, and you can see that basically it's a very similar type of problem. Okay, so it's just a matter of how you see it. But we can turn it back around and we can create the proportions. So our equation would be 6 over x plus 5 equals 3 over x minus 3. So we've got that proportion. We have to solve this equation, solve it for x. Again, the strategy is to cross multiply, which would give us 6 times x minus 3 equals 3 times x plus 5. Be certain to put these in parentheses. We then distribute on the left to get 6x minus 18. On the right, we distribute to get 3x plus 15. And then this is just like any other algebra problem. We just have to be careful we don't make any silly mistakes. Okay, so far so good. Get 3x equals 33, x equals 11. Okay, and now we can put that down as our answer, x equals 11. If we want to double check, 6 to 16, okay, that would be the ratio we would end up getting, 6 to 16. Is that equal to 3 to 11 minus 3 is 8. Let's see, is 6 over 16 equal to 3 over 8? Yes, obviously it is. So we correctly solved that problem. Let's move on to problem number 9. So we're back to triangles again. And again, don't let the position disturb you or fool you. You could turn this around like such, so that the parallel lines, so that the parallel segment is parallel to the line at the bottom. But we don't need to do that. We can solve it in any direction that we choose. So let's go ahead and create the proportions. So here we've got 6 is to x minus 5, as 8 is to x minus 2. Okay, and this is just yet another equation to solve. We need to cross multiply. That would give us 6 times x minus 2 is equal to 8 times x minus 5. And now we distribute. 6x minus 12 equals 8x minus 40. Again, simple algebra. Just make sure we don't make any silly mistakes, most important thing. You see, I almost made a silly mistake there. This is negative. Okay, I almost copied it down wrong. And you know, we all make mistakes, but we have to be just double checking our work like I just did. I just double checked and found that I made a mistake. Now I've got to add 40 to both sides. And that gives me 2x equals 28. X equals 14. So the answer to this equation is x equals 14. And I'm going to double check it by plugging it back in and seeing that it works. So if x is 14, this would tell me on the left side here that 6 is to 14 minus 5 is 9, as 8 is to 14 minus 2 is 12. So is that true? Is 6 over 9 equal to 8 over 12? Yes, because they both equal 2/3. So 2 times 3 is 6, 3 times 3 is 9, 2 times 4 is 8, 3 times 4 is 12. They are in the same proportion, and so we have the correct answer for number 9. Let's move on to problem number 10. And problem number 10 is a parallel proportion problem. And the information we're given here is just a little different. Okay, we know that this segment is 10, this segment is 3x. We know this segment is 6. We're told that this entire distance from here down to here is 15. So we know that this segment here has got to be 9, right? Because 9 plus 6 gives us 15. So we had to just fill in that little bit of a gap, and now we can go ahead and we can complete the problem. So we know that 10 is to 3x, as 6 is to 9. And we can cross multiply, giving us 90 equals 18x. And if we divide both sides by 18, we find that x is equal to 5. Okay, so x equals 5. And to double check, let's put x equals 5 in here. That would make 3x equals 15. By the way, I'll write down x equals 5 here. 3 times 5 is 15. 10 to 15 is again 2 to 3. And 6 to 9 again is in the ratio of 2 to 3. So x equals 5 is correct.